The M8300 multi-phase weaving machine can insert several weft threads at the same time. It is based on the multilinear shed principle, the sheds being formed on the circumference of the weaving rotor. The warp ends pass over the rotating weaving rotor. The sheds are formed consecutively on its circumference by shed-forming elements. The curvature and motion of the rotor causes these shed-forming elements to open the sheds one after another. By minimal movement of the warp positioner, the warp ends are positioned such that they are either picked up by the shed-forming elements and form the upper shed or remain in the lower shed position. Each warp thread is inserted individually into the eye of a warp positioner. Owing to the extremely low mass and short stroke, they can move at very high speed. Because the motion sequence of the warp positioners is controllable, the M8300 is capable of producing a variety of simple standard fabrics. The second function of these shed-forming elements on the weaving rotor is to form a weft channel. The weft is inserted into this channel by low-pressure compressed air over the full width of the fabric. Reliable weft transport is ensured by additional nozzles between the shed-forming elements. The 4 weft threads are drawn from stationary bobbins by metering rollers, simultaneously and at a constant speed. This speed is a function of the weft insertion rate and the weaving width. Beat-up combs located on the weaving rotor between the rows of shed-forming elements perform the function of the conventional reed. The lower shed, which rises after insertion of the weft, lifts the weft out of the weft channel over the entire weaving width. The beat-up comb behind the weft then catches up with it and beats it up.